Electronics is a field of physics and electrical engineering that deals with the study of phenomena in semiconductor elements, the study of the principles of their operation, and the use of devices and systems built on their basis. Elements of semiconductor electronics are made of natural semiconductors, germanium, silicon, selenium, gallium arsenide, etc. Semiconductors are substances that by their specific conductivity occupy an intermediate position between conductors and dielectrics, and differ from conductors by a significant dependence of specific conductivity on the concentrations of impurities, temperature, various types of radiation. The outer shells of semiconductors such as germanium and silicon contain 4 electrons. In a crystal, the outer shell of neighboring atoms overlap, and the electrons move in orbits that are common to 2 atoms at the same time, forming so-called covalent or pair electron bonds. Thus, a covalent bond, pair electron bond, is a chemical bond between 2 atoms that occurs when 2 electrons belonging to these atoms are generalized. A bond formed by one common pair of electrons is called a single bond. In addition, there are double and triple bonds. In the case when the crystal is formed by atoms of only one element, all electrons are connected by a covalent bond. One way to give electrons extra energy to break covalent bonds is to heat the semiconductor. As the temperature increases, the atoms begin to oscillate more actively at the nodes of the crystal lattice, which leads to the rupture of covalent bonds and the release of electrons. When an electron breaks a covalent bond and becomes a conduction electron, instead of it, there is a vacancy near the atom, which is called a hole. The process of forming an electron-hole pair is called generation. In the process of generation, the additional energy required to break the covalent bonds is absorbed. Electron-hole junction, or p-n transition, is the area of contact of 2 semiconductor regions with different types of conductivity. These regions are created in the structure of the semiconductor crystal by introducing the appropriate impurities into different regions of the crystal. The internal field EVN of the electron-hole transition prevents the transition of the main charge carriers from one region to another, but at the same time facilitates the transition of non-basic carriers, as it will be accelerating for them. Non-basic carriers carrying out chaotic movement within the respective regions of the crystal are picked up by internal field of the p-n junction and transferred to the regions where they are the main ones. A semiconductor diode is a device that contains one p-n junction, has 2 external terminals, anode A and cathode K, and is characterized by 2 steady states, open and closed. The anode is an electrode pin of the diode connected to the zone with p-type connectivity. The cathode is an electrode output connected to a zone with n-type connectivity. Barrier-caps are diodes whose barriers capacitance of the p-n junction varies depending on the reverse voltage applied to them. As the voltage increases, the capacitance decreases. Barrier-caps are used in schemes of automatic frequency turning, amplitude and frequency modulation, schemes of parametric amplifiers. Schottky barrier semiconductor diodes with low voltage drop with forward turning, in which we use metal semiconductor junction instead of p-n junction. Areas of use: DC to DC converter, mobile telephony, and chargers.